All right, welcome everybody. October 4th, 2025. I was about to say happy Monday, but I realize it's a happy Tuesday. So our webinar today is advanced framing techniques for high performance homes. And if you've tuned into some of our previous webinars, or if you go to the link that Rachel has shared with us, you'll see we have touched on different types of framing techniques before. I've done one on double stud wall framing. So we do have more information, but what we're going to do, or what I'm going to talk about today is advanced framing, and why. As energy codes become more stringent, builders and design professionals are under increasing pressure to deliver high performance homes without significantly increasing costs. And with this section, what we're going to do is explore some advanced framing techniques and construction methods that optimize material use and improve thermal performance to help professionals meet or exceed new energy efficiency standards. We're going to do an in-depth look at how strategic framing adjustments can reduce thermal bridging, increase insulation space. This session will cover practical details and give you some examples of how these details can be achieved. And for the AIA people, our learning objectives understand the principles and goals of advanced framing and how they differ from conventional framing. We're going to identify some specific techniques, evaluate how advanced framing contributes to compliance with current energy codes, IECC. And also, we're going to touch very little bit about voluntary standards such as Energy Star. And so hopefully we can touch on all these things rather easily. We won't go into super details on a lot of these, but we only have an hour, so we're going to try to touch on these as quickly as we can. Okay, agenda: framing fundamentals, advanced framing techniques, code considerations, and we're going to do a little bit of a wrap up if we have time in a Q&A. First, I want to sort of talk about, when we say conventional framing, what do we mean by conventional framing? I think if you've been in the industry for more than 20 years, you can remember back when 2x4 framing was 16 inches on center. And, when we think about conventional framing, that's really where we're going back to. It's still platform framing. Each floor is built as a separate platform. We all understand platform framing. Vertical studs support the load and create cavities for insulation. Headers and corners, extra lumber is used around windows, doors, and corners for strength and nailing surfaces. And it's a flexible way of construction. That's why it's so popular here in the US. But we're going to sort of touch on some of the techniques used in conventional framing and how they're going to differ from when we move into advanced framing. And also some of the drawbacks of conventional framing here. We get a higher framing factor. That word framing factor or framing fraction is going to come up a few times throughout here. And we'll get into the details of what that actually means when I say framing factor or fraction. And the cause and the effect of that higher framing factor is you use more wood. Anytime you use more wood, you're using less insulation. Every time you're using more wood, you have higher material and potentially higher labor costs. And there's really and we'll talk about this, there's no structural benefit to conventional framing over advanced framing. That's one of I think people get concerned about. Maybe it's not structurally as strong as conventional framing, but we'll sort of explain. I'll try to explain exactly how it is. And we're going to start with a quick overview. What is advanced framing? It says right there, a collection of optimized wood framing strategies for performance and efficiencies. We're going to cover quite a few different techniques when we say advanced framing. Some of them are going to be way more obvious to you than other ones, and some you're going to be like, yeah, I can easily bring that into my building practices. And some of them you're going to look at like, that's not for me. I mean, these are things that are, for the most part, not a requirement when we talk about framing. and I'll explain that as we go along too. But they're just a way of optimizing both material and increasing energy efficiencies in a home. What does advanced framing do? The main benefit of advanced framing is to reduce framing fraction or framing factor. You know, if you've been in this industry long enough, or not even long enough, but if you travel from one part of the country to another, people call things different things. I'm gonna use mostly framing factor, but it's also a framing fraction. It's a math problem we're talking about when we talk about this as well. The framing factor, also called framing fraction, or framing to wall ratio, represents the percentage of percentage of the wall's total area that is made up by framing members, which includes all your studs, your plates, your headers, etc. Any wood material that you're using to frame that wall assembly is what we're going to be talking about. And again, when you reduce this framing material, you increase the amount of insulation that goes into that wall assembly. Some more advantages of advanced framing: cost effectiveness. With the increased cost of lumber, ever since COVID came through and we had that little bump of lumber cost pricing, it hasn't really come down a whole lot. We get some slight fluctuations, but lumber is one of those commodities that has stayed up a little bit. So we were always trying to find ways of reducing the overall cost of a home, and that's one of the big things that's talked about now with residential construction and home ownership is how can we bring down the cost? And this is not a huge way of bringing down the cost, but it will bring down the cost. And every little bit, I believe, helps. And we talk about sustainability, many of the techniques used in advanced framing to fit well with many green building strategies. And energy efficiency. Advanced framing is not only cost effective for the builder when considering cost of lumber and labor savings by reducing the amount of wood, you are simultaneously increasing the amount of insulation in a wall cavity, which leads to overall greater efficiencies and an increase in the overall U value of the wall assemblies. Anytime we can make a house more efficient, we're reducing the overall cost of ownership to the homeowner who's taking over this home. So the more energy efficient, not only is it sustainable, it's more cost effective as an owner as well, for the owner as well. Energy impacts of framing. How does framing impact energy? Framing affects the heat loss, infiltration, and energy modeling results. Framing is the main culprit for thermal bridging when we talk about efficiencies of wall assemblies, and I will talk about thermal bridging a little bit more here. If you've tuned into things we've talked about before, when we talk about framing or any of our energy code updates, we talk about thermal bridging. And so if you're unfamiliar with what thermal bridging is, we know what a bridge is. It's a way of moving from one side to another when we talk about a bridge over a creek. Thermal bridging is basically the same. It's a way of energy to bridge the gap between the outside of the house and the inside of the house. And wood is not a good insulator. It has an R value of approximately 1 per inch. So those are places within the wall where we're creating a bridge between the outside and the inside, or the inside and the outside, where energy can travel easier. Thermal bridgings in a wall assembly are areas of less or no insulation. And I want to point this out too. We will never eliminate thermal bridging. You just can't. The law of thermodynamics is what it is. We cannot stop that move of energy from one area to another. But what we're really trying to do is create choke points and restrictions which allow that to happen. And by reducing the amount of wood or the amount of bridging within that wall assembly, that's one of the ways we're doing that. There's other techniques for doing that as well, but we're going to mostly talk about framing when we reference thermal bridging in this presentation. And here's some impacts of thermal bridging. Here's just an example: a 2x6 wall with R19 insulation does not have, like, we think, all right, we put that R19 wall insulation in that wall, we have an R19 wall, but you actually don't. you don't have an overall wall value of R19. You know, in research, I pulled this from the research, is that Oak Ridge National Laboratories determined the whole wall R value to be closer to actually R12. And if you don't install the bats properly, you can be down to R11. And that right there is a direct result of thermal bridging. Um, if you could theoretically have a wall with no wood in it at all, and it's just R19 insulation the whole way, and if it's installed properly, yeah, you can get close to that R19 number. But because of thermal bridging, um, it doesn't. So it really affects the overall R or U value when we talk about the wall assembly itself. Thermal imaging, here's an example, and you can actually see here. I don't have a picture of an advanced framing, but this is what we look at when we see thermal bridging in an IR camera. This is a very strong, very pronounced. This is definitely older conventional framing when you see how close those studs are together. But you can see when we talk about thermal bridging, you can see areas within that house and areas that have insulation and that don't. And a little visual comparison when we talk about advanced framing to conventional framing. It's flipping back and forth. This actually diagram I pulled out of the APA Wood website, and it just shows the dramatic difference between advanced framing and conventional framing when we talk about the amount of lumber. Now, there's some things in there that make it look like it's the same, but there's a pretty dramatic difference when we talk about the amount of wood within this wall assembly. Not all the techniques that you see here are techniques that you might want to use, but we're going to try to touch on some of these. You can see like the jack studs disappear. They're using header clips. They're using a single top plate. At their wall intersection points here, they're using cross bracing rather than, the two stud intersection point there, but we'll talk about that as we move on. And a little side-by-side comparison when we talk about conventional framing and advanced framing. Obviously, some of the aspects are stud spacing. We're going from 16 inches to 24 inches on center. I think most people now are using 24 inches on center. It's just that's what we have to do to be able to create that cavity large enough to get the insulation level high enough to reach our R value requirements on our fenestration table. Conventional framing corners, we're old school 3-stud corners. We're really moving on to, we're going to talk about 2-stud corners for better insulation optimization. Headers, you got double 2x10 or 2x12 at all openings, insulated headers, size to load. That's advanced framing. Top plates, double top plate everywhere, single top plate with truss and joist alignment is a technique of advanced framing. When we talk about top plates, what is a framing factor? Conventional framing factor, like I said earlier, you're looking at between 23 and 25%. With advanced framing, we're trying to get that down to at least 90% or lower. With an insulation space, conventional framing obviously is reduced, and we're maximizing with our 24 inches on center. And material use, we are actually using less material when we talk about advanced framing. It can be a pretty significant amount of material usage. And we get an effective overall higher R value. So we'll just take some of the details here. When we talk about details, you're going to see me show some examples of things. That doesn't mean this is the only way to achieve this. It's just some of the most common ways out there. But there are multiple ways of framing, but so don't take everything here and look at me like this is how I have to do it. It's not necessarily the case. Design the headers on the type of wall being load or non-bearing walls. This is an example here. You're seeing a non-load bearing wall, and there is no header. I recently went by a job site a few weeks ago, just a conventional builder that I saw, and they were actually still installing headers over a non-bearing wall onto over openings in a non-bearing wall. So you have to be, you know, conscious of where. I know if you have a young framer in there and they're just framing away and that's what they know, but you gotta start paying attention. People can start paying attention to like, do I actually need this size header? Am I oversizing things? You want to start to looking at your details more closely when we talk about installing headers and things like that in non-load bearing walls. And to talk about headers a little more, this is mostly site-built headers. There's many different ways to order headers now. You can order, prefabricated header material. Um, you can still use the old 2x method where you're installing 2x material. But we want to start, and we're going to talk about header insulation a little bit later when we talk about compliance. Um, but there's different ways of insulating your headers, and really how you insulate those headers also might determine, all right, do I want the material on the inside or the outside? If you're going to insulate on the exterior, as you can see on the diagram on the right, you get better building performance insulation to the exterior. And that's really going to create a break. Are you looking to create your thermal break on the inside or the outside of that header? It and there's really no wrong way or right way to do this at this point. The most important factor here is making sure that you're getting the proper insulation or as much insulation as possible into that header plate, into that header material. And obviously you can buy pre-manufactured headers. They're going to be a little bit more expensive, but you know, installation costs might be a little cheaper because it's a little faster. And it's a little less thinking involved. If you want to make sure that your crew is actually installing things right or installing insulated headers correctly, this is an easy way of making sure that they are you're not taking some of the worry out of you when you're not on the job site, that's being done properly. Another thing we can talk about when we talk about headers and advanced framing are reducing the jack studs. This is not a very common method of construction here. Just because people like to have that jack stud in there, not only for holding up the header, but also it creates a better nailing surface for when we talk about trim details. And there's things that you can do around it, but and when you talk about cost as well, it's almost the same cost to buy that header clip, that supporting header from Simpsons or wherever you're getting it, as it costs to buy that piece of 2x material. So as far as the cost goes, it doesn't really help with cost, but it does help with lowering the overall U value of this wall assembly. Again, we're removing wood in a location, then we can put more insulation. So not all of these techniques are necessary, but if you're really looking to dial in, if your goal is to get your wall assembly as efficient as possible, header clips are another tool that you can use to reduce your overall framing factor or fraction. And there's like little techniques there on the right. I included this diagram that shows you can put nailers in there if necessary to help support your trim details and your trim material. And again, here are some of the concerns of header clips. Load requirements still apply. These are engineered. You want to make sure you're using the correct size header clip that's engineered to support the size of the header that you're putting in. Jack studs and conventional framing transfer vertical loads from header down to the sole plate and foundation. We know that, and these clips are taking the place of those. And I already talked about, bottom line, details need to be thought out. And one of the biggest concerns I think people are going to have is the trim details and how you're going to attach, your interior trim and your exterior trim as well. Corners. This is a big one. Traditional frame corners, as you can see here, there's not a there's no way to get insulation into this corner. Like when I started in this industry many, many years ago, this is how we framed corners, you know. Corners were just areas of connection, you know, on the exterior outside of your framing assembly. And you always wanted to make sure those were strong, those connection points were strong. So, you know, your building would be safe. Um, you know, and what we want to move forward with, especially when we talk about increasing the overall R value of our wall assembly, is removing some of that material in a way that allows us to get better insulation or into the back of the corner. Now, I mean, I theoretically you could, sorry about this. I got a little You could jam some insulation in there as long as your sheathing's not in place. But anytime you try to pack insulation into a cavity that's like that, it's not going to be very well. And you're still bridging multiple spots in this corner. Now, if we want to talk about, we're going to talk about insulated corners. It allows more insulation in the corners compared to traditional three-stud corners. Um, you know, and here's two different ways of doing that. Now, the one on the left there, that diagram on the left is a typical two-stud corner. We're all familiar with those California corners. And these are great that you can still insulate that corner all the way back, you know, as far as you need to insulate it. So you've pretty much reduced that thermal bridging in that corner. Now, you got to be careful here when you're insulating these types of corners, is that if you're using like a fiberglass insulation, you don't want to compress that fiberglass insulation to get it back in that corner. You're going to have to do something a little different. Maybe you're going to use some, you know, foam board insulation cut to the the width of that that stud you're using there as your corner. But you want to make sure that you're not compressing or installing insulation poorly in that corner. You still want to make sure you're installing your insulation correctly. Now, the diagram on the right shows only a single stud, but because we don't have that second stud there, we need to take into account how are we going to hang our drywall. And that's really why that second stud's there. And you can use things like drywall clips. These are not very common. This is not a very common way of installing because it can get a little wonky sometimes if you're not really good at installing these clips. This is something you probably want, if you're going to go this route, is talk to your drywaller and see if they want to be the person that installs these clips. I'm going to say they probably are going to be the person, even if they are familiar with using these drywall clips. And the thing about these clips, they're great structurally. You know, you're not going to get any more cracking by using these drywall clips generally than if you were put that second stud in there and fasten your drywall to that stud. They're designed specifically to carry these corners, these clips. So, but by using those clips, you can see there, you can just use your fiberglass insulation all the way over to that exterior stud. You don't need to use like a foam board or some other type of insulation back there to make sure you're not, you know, reducing the R value in that location. Wall intersections. Traditional T-post intersection is we're familiar with. You know, space may be insulated from the exterior, but traditionally it is left open. And it leaves a large 3 to 6 inch section of the exterior wall cavity poorly insulated or not insulated at all. And again, you're bringing in more, you know, anytime you bring in, unless that wall intersection lands on a framing member or a wall stud, like a common stud, you're going to have to not only have your 24 inches on center studs, now you're introducing more vertical framing material between those 24 inches on center where you're not going to be able to get insulation. You're just bringing in a lot more framing material into this wall assembly. And again, we're trying to get that framing material out of this wall assembly as much as possible. A few different ways of addressing this. Um, Ladder blocking at intersections is the most common type we see now. It doesn't mean it's the only way, but this is probably the most and the easiest for people to understand. Simplifies connections and preserve insulation space, allows for better insulation at wall intersections. As you can see here, there's no bridge here anymore between the exterior and the interior. We've eliminated those two framing members. So we've eliminated the thermal bridging at that, or reduced the thermal bridging at that intersection. And this is what it looks like on the job site. I pulled this picture right out of the APA. They have a PDF manual. This is an excellent manual if you really want to dive into more details about advanced framing and how it's used and the benefits and potential drawbacks might be. But as you can see here, this is what we consider, it looks like a ladder, literal lateral. So, but you're starting to introduce more material into your wall assembly. And what you got to be more careful with here is if you have a 2x6 wall cavity and you're using a 5.5-inch insulation design to fill that wall cavity, you're starting to start getting some compression at this point where you're having to slip it behind these pieces of 2x material. And that does start to compress, and it does start to affect the R value of that insulation. It's not a whole lot of space, but it is starting to affect the quality of the insulation installation. And how some techniques for sort of eliminating that. One of the things you can do is support post-wall intersections. So I've seen this a few times. Um, all you're doing is literally installing a piece of, say, 1x6 on the back of that, if it's a 2x4 wall that's intersecting. Now, if it's a wet wall and you're using a 2x6 there, then that's going to be a little different. Then you're going to have to find something else to go along with that. But you're what this 1x6 does is all that is this is a connection point for your drywall. And that's what the ladder is as well. With the previous slide is those ladders are realistically their main objective is as a connection point for. It does add some stability and it does add some rigidity to that wall assembly, but it's also mainly there so your drywall has something to attach itself to. Because once you nail that wall to the floor, the base plate, and you connect your top plate, that's a pretty rigid wall assembly there. So by using a 1x, you're really only compressing that insulation 3/4 of an inch. So it's really not compressing that much. The benefit of using the ladder system is there's a lot of scrap lumber laying around your job site. So that's the easiest thing to do. You just got to be careful you don't have somebody in there throwing like 5 or 6 pieces of ladder in there, and you're just making it a lot harder to get insulation in as well as compressing it. And there's clips as well. You can use drywall clips when we talk about these connection points as well. And again, it's a technique not used very often, but that is an option. You can use drywall clips. And if you happen to use a single top plate, which we'll talk about here next, that connection point is you're still connecting at the top like you need to. But again, this right here, this advanced framing technique for a wall intersection, you're limiting all extra lumber within that wall assembly, and you're just using drywall clips. So you can insulate that cavity. It'll be insulated like every other cavity within that wall assembly. Now I'll talk a little bit about single top plates, not a whole lot. This is, I think, one of the areas where people are less likely to get into advanced framing. There's a lot of things that have to be thought about when we talk about using single top plates. But it is a technique that you can use. You are eliminating some material when you go from a double to a single top plate at the top of your wall assembly, but you're introducing some other potential headaches as well. So this is a very uncommon, mostly uncommon thing, unless you're really getting into like advanced framing, like passive house design, where you're really trying to get your framing factor down to as absolutely low as possible. And when, like I said, there's things that you have to consider when you're going to consider a top plate. Is one of those things to consider is your bearing. You know, you can't use, you got to be more conscious, and we got to use what's considered what we call stacked framing, where if you have that single top plate, you want to make sure that your rafters are bearing directly over your wall cavity stud. So you're transferring your wall loads, you're transferring all of that directly down, um, down your wall assembly there. You know, we all understand structures when it comes to load. We all understand, you know, how to transfer loads from the roof. We're transferring everything down to the foundation. And I am not 100% sure on the code language on this, but I think if you're doing the stacked framing and you're stacking your studs underneath your rafters or your rafters over your studs, you have to be, I think, within 3/4 of an inch of alignment. You pretty much have to be right on. You can't offset that, you know, at all. Playing on zero is what you want to think about. But it is a possibility. When we talk about, you know, single top plate between floors, you know, you have a rim joist which acts as a header at that point. So there's a little, your concern there, your load transfer is a lot easier when you think about that than it is on your load transfer when you talk about where your rafter meets your top plate. And raised heel trusses, these are becoming a lot more popular, just because of the R value requirements, but they are a type of advanced framing. You're not going to frame these things on a job site. This is something that you're going to think about when you're ordering your trusses. You know, it is an element of advanced framing. It improves overall efficiency, creates space for full cavity of insulation up there, eliminating a lot of thermal bridging again. But yeah, this is something that is considered a part of advanced framing. All right, advanced framing and energy code compliance. I'm going to touch on certain things slightly and try to maybe get a little bit more in depth in certain areas, but this is just how advanced framing plays into energy code compliance when we talk about Pennsylvania. You know, again, if you've been to one of our webinars before, PA UCC Regional Energy Code, you know, it's a combination, or it is the IRC, the IECC. We have our RAC amendments. That's the bit, and we have statutory amendments, which I'm not going to mention here, but those things are basically how our UCC is determined. We also have something what we call the Pennsylvania Alternative Residential Energy Provision, and I'll talk about that a little bit more in depth and why I think that's going to be important when we talk about advanced framing moving into the new code cycle that we're moving into, which is right around the corner. Advanced framing in the IECC, you know, the ICC doesn't mandate advanced framing in particular by name, but it supports and rewards its use because it reduces thermal bridging. Again, less wood equals fewer heat flow paths and increases insulation volume. This means builders can use advanced framing techniques to meet or exceed the prescriptive R value or U factor requirements for above grade wall assemblies, or improve results in the resident ICC 301 energy modeling pathways. And how it fits within the IECC 2021 compliance paths, you know, I've tried to make this as simple as possible. Prescriptive path, the compliance prescriptive path R402.1.2 helps meet required cavity plus of continuous R values. And by reducing framing factor and improving effective R values, a 2x6 24-inch on center wall might meet the R20 plus 5 or R13 plus 10 prescriptive requirements more easily. And if we're talking about R402.1.4, the U factor alternative, it lowers overall U value, reduces framing factors. You know, we're getting that framing factor down to where it needs to be out of that 25% range. And often qualifying walls for compliance even with slightly nominal R values. And then we got the simulated performance paths. Where we're modeling our performance paths. It's a method of boosting your model efficiency. In an energy modeling software, The improved whole wall R value from advanced framing yields lower energy use and better ERI scores. In the prescriptive path again, builders comply by meeting the minimum insulation. By meeting the minimum insulation, our values are maximum factors listed on table R402.1 for their specific climate zones. Again, this is a prescriptive path, just like if you just follow the IRC and you follow that prescriptive path, this is just already laid out exactly what you want, what you need to do. Each building component, such as walls, ceilings, floors, windows, doors, must meet or exceed these requirements. Advanced framing can help these targets by reducing wood, increase insulation area, and lowering wall factors. It's as simple as this. It's a simple path. You go to the table, you document your values that you're using, and you can pass inspection, hopefully. In the U value alternative, an assembly with a U factor equal to or less than the specific table R402.1.4 shall be permitted as an alternative to the R value in table 402.1.2. Even though this is a calculated method of a compliance, it is still considered prescriptive, not performance-based. So I'm going to move on through a little bit faster here, because I think my time is going to start getting into me here. In the performance and ERA path, which is R405 and 406, again, we're reducing framing factors. Less wood equals more insulation, which equals lower U factors for walls. Improved wall U factor lowers the total, making code compliance easier, can offset other upgrades. Bottom line, advanced framing is optional, but an effective way to pass the UA check without extra insulation cost. I'm going to throw this slide in here real quick. We do have a webinar, Beyond Prescriptive Evaluating Energy Code Compliance Paths. And if you go to the link that Rachel included, it's a very good webinar that goes really into detail all those alternative compliance paths, which I just talked about there. If you're interested in learning more about those, please go in there and watch that. It's by a really good member of who supports the PHRC, by Mike Arblaster, and he gives some really great information on all those things I just talked about. But what I want to do is talk about the PA alternative a little bit, because it's put out by the PHRC. It's a approved alternative compliance path for the 2021 IECC/IRC Energy Code as adopted by the Pennsylvania UCC. Makes simpler to build and enforce. It's more flexible and rational. It's specifically tuned for Pennsylvania's climate and construction practices. So it's specifically designed for Pennsylvania and the Pennsylvania UCC. And like any other prescriptive path, what we've done here is we've done the modeling for you. So you don't have to, this is a non, it's like it's like a performance path, but in prescriptive form. So since we've done all the modeling for you, it makes it easier for a builder to look at this and understand exactly what they need to do as far as what we call trade-offs are concerned. And trade-offs are, a performance path is you have trade-offs. So if you are more efficient in one area of your building, you can be less efficient in another area. But what we want to do is we always want to make sure that we are balancing these trade-offs and requirements with the UCC code requirements. So we're always aiming at having that overall wall assembly still maintain that required U value or overall home value, the U value, but we're doing it in a little bit different way. And with the new energy code requirements adopted by the UCC, I think the PA alternative is going to be a really good way for people to meet the future energy code requirements. And here's just the table for our energy enhancement options. I'm not going to go on here and talk about this very much because it's pretty self-explanatory. These are just what you would look at as a builder to say, all right, I can pick one of these things and I can have trade-offs throughout the rest of my building assembly. I can use all the trade-offs that are spelled out in the Pennsylvania alternative by just using one of these enhancements here. What I'm going to talk about is a trade-off, energy trade-offs, going to be comes to wood frame wall R value, cavity only wall insulation. And this is pulled out right directly out of the PA alternative. And you can see here we have our two climate zones. And if you're not familiar with what's going to be happening in the next couple of months, when the new code comes into compliance, Pennsylvania is going to reduce our climate zones from 3 down to 2. We're losing climate zone 6, and we're just going to be climate zones 4 and 5. You can see here, climate zones 4 fenestration R value and fenestration requirements are, we're going to have an R20 cavity insulation or R13 5 exterior, and construction zone 5, which is the majority of Pennsylvania. It's probably close to 3/4 of Pennsylvania. We are going to an R23 cavity insulation. But that's directly out of the UCC. So if you go to the IRC and look for this at the fenestration table, it's not going to match. You actually have to go to the rack amendments to see the new fenestration table requirements. But back to my point is, you can see 4 and 5, there's little notes, and 20 has a footnote of G, and the climate zone 4, R23 insulation has a footnote of an H. Now, what are those footnotes spelling out? And those energy trade-offs again, and here's where the notes are spelled out, which would be below that. Footnote G, R18 insulation shall be permitted in place of an R20 requirement, provided the construction of the wall is of the advanced framing type. That's where we're getting to the advanced framing part of this, has a framing fraction of 19%, and insulation is installed per ANSI ResNet ICC 301-2022, section 4.2.2.1 in table 4.2.2 parentheses 6. So again, you can see what we're saying here is, sorry here, let me get back to where I was here. I'm having a little bit of right here, R20, you're able to reduce that R20 down to an R18. And the R23 here, that was the H note, R20 insulation shall be permitted in place of the R23 requirements, provided the construction of the wall is of the advanced framing type, has a framing fraction of 19%, it can be less, and insulation is installed per the ANSI ResNet ICC 301-2022, section 4.2.2.1 in table 4.2.2.6, parentheses. Again, what's that table? So the 2022 ANSI ResNet ICC table, you can find this online pretty easily. And it sort of spells out exactly what that section details. 4.2.2.1, a framing fraction shall be designated for each segment of framed wall. And it actually breaks down what they refer to as a segment. A segment is basically from the top plate to the bottom plate, and from the wall assembly itself, from the left to the right. So that is what's considered a wall assembly. A wall segment is defined as a planar section bound side by side by the walls, corners, top and bottom plate, and the bottom plate. Now, some of those wall assemblies might be slightly different. Your framing fraction might be different in different wall assemblies. Say you have trouble framing for some reason, something. So, but what we're always trying to get here is a framing fraction of 19%. That's what you need. If a different framing fractions are designated for different segments of the wall, of the framed wall, floor, or ceiling assembly, then the multiple entries are permitted to be entered into the rating software. So you can have different percentages of wall assembly, and they can be put into the software individually. Alternatively, the entire assembly can be modeled with the highest designated framing fraction. For ratings where the framing is not visible at the time of site inspection, the framing fraction shall equal the highest default framing fraction of the assembly component listed in table 4.2.2 parentheses 6. Again, they're saying if something happens, that wall assembly happens to have drywall put on before it is inspected, you automatically default to the highest framing fraction. And I can show you what those are now. You can see here, this is table 4.2.6, 4.2.2 parentheses 6, the default framing fractions for wood framed assembly components in your wall assembly. If, say, we're just going to look at the 2x6 one here on top, if your default, the highest number there is a 25% framing fraction. So that is not what we want. So you want to make sure that if you're going to the bother of doing all this advanced framing, you want to make sure that it's able to be inspected. Now, to get to the advanced framing, to get to that ability to use this, you need to get to that 19%. And it says right here, the frame type of the framing type has to be of the advanced type framing to qualify for that 19%. To get you to that 19%, and then you need to be at the use advanced type framing fraction. I'm sorry, assembly. And what does that mean? 4.2.2.1.1, the default framing fraction for the advanced framing type, that's where we're at, that's what we're looking at, are permitted to be used if the wall segment complies with all the following. So you have to use all of these advanced framing strategies to qualify. And we've talked about them all. Corners of cavity shall be completely filled with at least R6 or greater insulation. So you need to make sure that you can get R6 or greater insulation into your corner cavity there. So if you are using fiberglass insulation and you're compressing that to get it in there, you're reducing that insulation ability. Now, I think the easiest way to do that, again, is probably foam board, but you want to make sure that you are complying with that portion. Intersections with interior walls shall be insulated to the same R value as the remainder of the wall assembly. And again, we talked about those wall intersections. You want to make sure you can get your fiberglass insulation in there and installed properly to how it's supposed to be installed by required. And then headers of framed wall shall be insulated to at least R3 or greater for a 2x4 wall assembly or equivalent cavity. And unless you're using a 2x6 wall cavity, then your header insulation has to be at least an R5 or greater. And framing shall be limited to all windows, doors to one pair of king studs and one pair of jack studs per window opening to support header and sill. So no multiple jack studs when we're talking about, larger openings. If you have an opening that you were traditionally put in 2 jack studs to support that header, that's not permitted. Now, if you're having trouble with this, there's also another way. You got 4.2.1.2.1.2. You can have an engineer, the assembly specific framing fraction needs to be at least 19%. And if you don't go by just by following all the conditions above, you can have an engineer design an assembly, a framing assembly that meets that 19% target that we're looking at to qualify as an advanced framing type. And again, what we're doing is we're getting our insulation from the traditional down to from 25% down to at least 19% or less. Energy Star, if that's a different beast here than what we're talking about. And there is framing when we talk about framing requirements for Energy Star, when we talk about our checklists. Since we're at 155, I'm going to go through here. I'm just going to show you the checklist. And you can see part 3 down here. If you're familiar with Energy Star, not a lot of people use this method, but if you do, you can see down here when we talk about thermal bridging, all the way down here, you can see section 3.4.3, advanced framing, including all of the items below, basically almost listing all the items we just talked about before. So advanced framing, yeah, it's important. And it's important, especially when we start talking about these alternative pathways, when we talk about complying with our energy options. Architectural and design coordination. This is going to be pretty important, especially if architects and designers are are talking to new framing crews, if they're talking about to new people they're not used to working with, and they want to make sure that they're coordinating these details specifically. It's important, uh, you know, communication between the design and the field is critically important, especially when you're doing things that aren't traditional. Um, you know, things get lost. It's like the old thing where some person whispers and another. We all did this in school, where we pass information down the line. By the time it gets down to the crews framing the wall assemblies, if the coordination and the communication is not clear, we could have issues. Yeah, we want to make sure that that's taken care of. In trade coordination, not only do we want to talk to the framers, and when we talk about trades, we also want to make sure we're talking about changes to framing when we talk to electricians and things like that, HVAC technicians. Advanced framing isn't just a frame tweak, it changes the stud spacing. It changes our corner and header configurations, our single top plates and stack framing, and reduces extra lumbars at openings and intersections. Because of those differences, other trades can't just build as usual. They might have to make some considerations when they're talking about what they do. Every penetration, fastener, or attachment point that depends on traditional framing now land in a slightly different place, especially if we're talking about single top plates over a double top plate. If those changes aren't communicated early, it can cause frustration, rework, and non-compliance on the job site. And then one way to do that is the detail callouts. Actually, if you might not have a framing plan, but if you're concerned about the framers or somebody not complying with what your description is, you might actually want to slip a detail in there, a drawing detail of those wall intersection, of that corner, and how you want that insulated specifically. It reduces ambiguity and prevents misinterpretation by providing all the necessary information, improves accuracy, ensures that components are constructed and installed correctly according to the design. And again, I like this engineered wood PDF. I printed this out. I have this. It's from the APA, but there's other versions of different things out there, and they go into really good details. And if you want to communicate this to a framing company or a crew, print this out. It's not very many pages, and give them to them. Make sure that somebody has access to this document if you're concerned. It helps eliminate some concerns and helps eliminate what we're trying to communicate. Key takeaways. Advanced framing is structurally sound when done correctly. Some people try to say that it's structurally weaker. It's not. You're still creating a structurally sound house. It takes no more time than conventional framing. It's too difficult for framers to implement. That is absolutely not true at all. Anybody who can do conventional framing can do advanced framing. Finished details are more difficult. They can be if we're talking about eliminating jack studs, if we're talking about single top plates, but generally they're not. There are things that we can do to sort of, like I said, if you're not using a jack stud, using header clips, we just install 2x2 backers for our trim work.